Might you, at some point, imagine that the completion of our universe might be the beginning of the next one, perhaps one that is entirely unique in relation to our own? Theories of the multiverse are nothing new in the field of cosmology, yet evidence supporting this speculation is emerging. The James Webb Space Telescope has recently delivered the first image of another universe. Since the earliest days of written history, people have looked up at the stars and pondered the sun, the moon, and the heavens. For ancient people, the sun and moon were seen as openings in the sky through which light entered a world they imagined as a flat disk. Over centuries, humanity discovered that we live on a sphere that rotates and orbits a star, one of countless stars and planets in an immense universe. Despite having powerful telescopes for about a century, we still do not fully understand space. Astronomers continue to uncover new features of the universe, solving old mysteries while encountering new ones. Until recently, we had no clue who or what created the universe or why. Nor did we know whether the universe has an end or is eternal. With our best telescopes, we have been able to see as far as 13.3 billion light-years away. When we look that far, we are effectively looking back in time, as the light captured by telescopes like Hubble has traveled through space for billions of years to reach us. These investigations into the past are fascinating. Scientists have been able to look almost back to the beginning of the universe, or so they thought for a long time. Then came the James Webb Space Telescope, launched in the summer of 2022 by NASA, the Canadian Space Agency, and the European Space Agency, ESA. Even its earliest images provided groundbreaking material, sparking intense debate among scientists. Today, 6 universes are hypothesized to have existed in the earliest epochs of cosmic history, with no clear explanation for their existence. Systems like Glass Z13 existed just 250 to 350 million years after the Big Bang, a timeline that is theoretically impossible. At this stage of cosmic evolution, only a few stars should have been slowly forming, requiring billions of years to coalesce into galaxies. So what does this mean? Is the Big Bang theory wrong, or is there an entirely different explanation? One possibility is that we are observing another universe. For example, the image of the galaxy cluster MAX J0647 plus 075 reveals a stunning view of galaxies shining like jewels in the vastness of space. What excites scientists about this image is not only its beauty but also its implications. This same region was imaged a decade earlier by the Hubble Space Telescope, but the details were far less clear. Back then, faint objects in the background hinted at ancient, distant galaxies, but their properties remained undeciphered. Now, thanks to the James Webb Telescope, we can see these ancient objects in extraordinary detail. Some of these galaxies are so old, bright, and structured that they make our Milky Way seem unremarkable by comparison. Astronomers are baffled by the data, particularly the brightness and luminosity. If the interpretations are correct, these galaxies have formed vastly more stars than our own galaxy, defying every current cosmological model. It appears that many long-standing assumptions in cosmology might be flawed. Scientists have based their theories on a framework that now seems misleading. This is a shock for those who believed in the existence of a singular universe, where everything could be explained through Einstein's theory of relativity. Meanwhile, many branches of physics have long suggested that it is more plausible for us to live in one of many universes, potentially existing alongside or even within our own. These universes may contradict our current understanding, as they belong to entirely different physical frameworks. One such discovery is the galaxy Glass Z12. Galaxies are often named after the observational systems through which they are detected. GLASS stands for Gravitational Lensing Advanced Systematic Studies, and Z12 refers to its redshift value. The redshift indicates the age and distance of a galaxy. According to current cosmological theories, Glass Z12, which existed 300 to 400 million years after the Big Bang, is impossibly ancient. The discovery of Glass Z12 was already a sensation in the academic community, but even more ancient and puzzling galaxies have since been identified. One of these is the candidate galaxy CR7-93316. This galaxy is so old that it existed only 250 million years after the Big Bang. Yet it exhibits an unusual property. Measurements of its redshift yielded 2 distinct values. At one point, it had a redshift of 16.7, suggesting extreme age, but measurements of neighboring objects gave a completely different redshift. It appeared to exist in two places and at two times simultaneously. Scientists jokingly refer to this as the Schrödinger galaxy, inspired by physicist Erwin Schrödinger's quantum theories, which suggest that two realities can coexist simultaneously. According to these theories, not only are multiple universes possible, but there could also be infinite variations in countless forms. Researchers continue to grapple with these mysteries, uncovering evidence that challenges our understanding of the universe and raises profound questions about existence itself. Estimation results and realized perspectives might, in any case, lead one to put stock in an estimation mistake or even uncertainty whether these marks of light are systems by any stretch of the imagination. While the spectroscopy evaluation to confirm the redshift is still ongoing, further information from James Webb's IR camera system has already completely ruled out the possibility of it being a low-mass star or an unnoticed active cosmic core. We ought to figure that the discovery of CRS 93316 was only the beginning of what is possible. NASA has suggested that the James Webb Space Telescope could potentially detect galaxies with a redshift greater than 20. These galaxies would have existed only 200 million years after the Big Bang. Or perhaps the telescope is looking much further into parts of our universe, which might confirm that we have encountered a constraint of existence unrelated to the Big Bang altogether. At this point, we can no longer discuss the beginning of humankind, the universe, or the time after the Big Bang. Instead, we change the phrasing and refer to it as the edge of the observable universe. There lies another fascinating source of light, which shows an incredibly high redshift value in our images, demonstrating that A2744Y1 is indeed a galaxy whose light has traveled more than 13 billion years to reach us. A group of scientists has combined the best telescopes on Earth, the Spitzer telescope, Tundra, and Hubble, to capture another image of this incredible galaxy by gathering data from various frequencies of light and merging them into one image. Not only is the age and distance of this galaxy astonishing, but the rate of star formation also surpasses anything previously thought possible in physics. Despite being many times smaller than our own Milky Way galaxy, A2744Y1 produces stars at a rate several times faster than that of the Milky Way, which is uncommon for a galaxy in a young universe. The observable universe currently has a radius of 46.1 billion light-years, but beyond that, there is likely much more. The better our technologies become, the further and more detailed our observations can reach. James Webb is theoretically capable of looking back 13.6 billion years. If the Big Bang occurred 13.8 billion years ago, there would ultimately be a limit to our observations. This is because a few 100,000 years after the Big Bang, the universe would have been entirely dark. The first stars are believed to have formed only after 380,000 years. If astronomers continue to discover even older galaxies, it will undoubtedly show that all previous cosmological assumptions were incorrect. Currently, experts at NASA are gaining initial insights with the new telescope, which have already been groundbreaking. However, we know that time generally brings new understanding, and in a few years, researchers might extract even more from the telescope's capabilities. Perhaps we could finally see what really happened at the supposed beginning of time. Although the hypothesis of the Big Bang seemed plausible for some time, there was no evidence to support its accuracy. With the rise of quantum physics, it became significantly more likely that our universe is an extraordinarily variable, diverse, and possibly complex place. Models of the bubble universe or pocket universe suggest that our universe is enclosed in a giant bubble and shares space with many other bubbles of different sizes. The pocket universe proposes that within a universe, there are various regions where similar yet different conditions might prevail. These pockets could provide access to different aspects or corners of the universe where alternative rules apply. There is as much evidence and speculation supporting these theories as there is for the Big Bang. The assumptions of the Big Bang and Einstein's physics were established well before the speculations of quantum physics. In the future, the combination of these models could lead to a deeper understanding of our universe and the multiverse. If this proves to be true, we might be living in a bubble universe surrounded by numerous other bubbles or in an infinite number of universes, each with its own set of physical laws. This would imply a level of complexity that goes far beyond our current understanding of the universe and our place within it. As we continue to explore and uncover new data, the possibility of discovering alternate universes and dimensions becomes increasingly likely, potentially reshaping our understanding of reality itself. Digging deeper into the implications of these new cosmic discoveries, we must examine the broader questions they raise about our universe and our place within it. One of the most significant questions is whether the universe we observe is all that exists, or if our observations merely reveal a much larger and more complex structure. The idea of a multiverse, that many, perhaps infinite universes exist beyond our own, has gained traction in both theoretical physics and cosmology. If the new discoveries made by the James Webb Space Telescope suggest the existence of galaxies that defy current understanding, it might be a sign that our universe is just one part of a much grander infinite tapestry. The multiverse hypothesis itself comes in various forms, each with different implications for our understanding of reality. One notable hypothesis is the inflationary multiverse, which suggests that during the early moments of the Big Bang, different regions of space expanded at different rates. This uneven expansion may have led to the creation of numerous distinct bubble universes, each with its own set of physical laws and constants. If this hypothesis holds, the universe we see might be just one bubble in a vast, multifaceted cosmic foam. Another fascinating concept is the possibility of a cyclic universe. This theory suggests that the universe undergoes an eternal cycle of creation, expansion, contraction, and rebirth. According to this model, the universe as we know it could be the result of a previous universe collapsing in on itself and then re-emerging in a Big Bang-like event. This cycle could theoretically repeat endlessly. It is one way to propose that our universe cycles through an infinite series of cosmic renewals. The discovery of incredibly ancient galaxies, like Glass Z12 and CRS 93316, poses significant challenges to our current understanding of cosmic evolution. These discoveries imply that there may have been processes occurring in the early universe that we do not yet fully understand. If galaxies could form and organize themselves so quickly after the Big Bang, it suggests that our models of cosmic evolution and the formation of structures in the universe might need significant revisions. This discovery could lead to new theories about how galaxies and other cosmic structures develop and interact over time. Moreover, the possibility of observing anomalies that appear to challenge standard models of physics opens the door to re-evaluating fundamental principles. For instance, the existence of galaxies with properties that challenge our understanding of dark matter, dark energy, and the behavior of light could require a revision of the standard model of particle physics. This could also prompt a re-evaluation of Einstein's theory of relativity and how it applies on the most massive scales. As we continue to push the limits of our observational capabilities, the role of future space missions and next-generation telescopes will be crucial. Instruments far more powerful than the James Webb Space Telescope. These advancements will help refine our understanding of the universe's history and structure, and may provide more clues about the true nature of the universe. Additionally, the philosophical and existential implications of these discoveries are profound. If our universe is part of a multiverse or if there are realms beyond our current observational limits, it challenges our very understanding of existence. This could impact not only scientific theories but also our philosophical and spiritual perspectives on life, consciousness, and the nature of reality. As we unravel more about the universe, we may find ourselves re-evaluating fundamental questions about the meaning and purpose of our existence. In summary, the new insights gained from the James Webb Space Telescope and other advanced observational tools are expanding our knowledge of the universe in ways we had not anticipated. These discoveries are not only adding new pieces to the cosmic puzzle but are fundamentally reshaping our understanding of the universe. As we continue to explore and learn, we stand on the brink of potentially groundbreaking discoveries that could transform our view of reality itself. The journey to understanding the true nature of the universe is far from over, and each new discovery brings us one step closer to unraveling the mysteries of existence.